Welcome to the video about how to use your scientific calculator for statistical purposes. So let's turn the calculator on, and now on the display I can see D and math. It's telling me that my calculator is in the mathematical mode using degrees. Now I want my calculator to go into statistical mode, so I need to press the mode and I need to press 2. And here comes all the different types of statistical calculations that I can carry out. First I want to do the one variable. So I'm going to choose that, and then what happens in here that I have come up with the statistical table where I can input my data. Right, at the moment I'm not going to put any data into it because I want to show you other types of statistical setups. So if I press Shift 1, those are that's giving me back the different types of statistical options now. Now if I press 1, what happens? I get back again what I had in the beginning of the statistical mode. So I can have one variable, I can have regression, I can have squared, I can have logarithmic, exponential, and all sorts of different types of statistical calculations. In this video, I'm only going to concentrate on one variable and the regression. The rest of them are very rarely used, but if you want to have more information about them, don't forget your user guide, which will give you a lot of information about how to use the rest of them. Okay, let's use 1. So if I go back to stats 1 again, what I have here is again 2 data and 3 edit. Press 2 if you want to input new data, and press 3 if you want to edit some old data. So we don't have any data in there, so we're just going to edit the data. At the moment here I only got one column, and that is just the data column. In some situation you might want to have a frequency column in here, especially if you have got many data repeatedly in your data set, so you don't have to write them out over and over and over again. So how to bring in this frequency column? You press Shift, Setup, come down, you press 3 for stats, and then you can turn on or off the frequency. Let's see if we choose 1, what will happen to the display. So we had X here, now we have another column called the frequency. Well, the data set I'm using is very small, so I'm not going to use the frequency, so I'm going to turn it off. Press 2. So let's input our first data set and see what we can do with it. So I've got my first data, 23, and if I want to input that into my data table, I have to press equal. And then what I'm going to do, 45 equal, 13 equal, 43 equal, 12 equal, 19 equal, 23 equal, 27 equal, and 43 equal again. So I've inputted all my data. What happens if I wanted to edit some of them? I can just use the up and down arrows and just overwrite the data. Let's say I pressed 43, but I wanted to press 45. So I can just rewrite that. But let's go back to make sure that I've got the correct data. So that was 43. So I've got all of the data now. What's important in here is that unless you deliberately delete the data set or exit from the stats mode, this is the data that you can use for all of the rest of the calculations. So even if I press the AC button and clear the screen, the calculator's memory stores all those data. So Shift 1, and now I have got data, sum, variable, minimax. We looked at the type and data already. Let's see what's in sum. So sigma x squared, sigma x. The difference between the two, that this is basically going to square every one of my data points and add them together, and this is just going to add the data points together. So depending on if you need the sum of the squares or if you just need the sum of the data, you can use 1 or 2. So the sum of the data squares appears on the screen, so you need to hit enter to get to the actual numerical value, which is for this particular data set is 8184. If you want sum of just the data, you need to press 2 and again equal, and that is just 248. So if I individually typed in that 9 data using the plus sign and hit equal, I would have ended up with the very same sum. However, in this case I only had to press a couple of buttons instead of going through that long input process. So what else is there in the statistical mode? So if I press 4, which is variables, what do I have there? I have there n, x bar, sigma x, and sx. N is the number of data. So how many data did we put in? We put in 9 data. Let's see if the calculator remembers correctly. Hit equal again. Yes, we did put 9 data in. So go back. We were on 4, variable. The next one is x bar. X bar is the mean of the data. So if I hit equal, the mean of my data is 27.555. Basically, the mean is calculated by summing up all the data points and dividing by the number of data. So I could have got to the mean by calling the sum of x and divided by the n. But this is a faster way of calling it. Let's see what else is in variable. Now in variable I have got sigma x and I have got sx. Now sigma x is the population standard deviation and sx is the sample standard deviation. When you look at the formula for the two of them, they are very, very similar, but in the population standard deviation formula we divide by n, while for the sample standard deviation we divide by n minus 1. So let's see if this small little difference shows up on the screen. So if I press 3 and equal, I've got the standard deviation for the population as 12.24. Right, let's go back, shift 1, 4 variable, and see what the sample standard deviation look like, which is number 4. Don't forget to hit the equal sign, otherwise, as you can see, it's still the population standard deviation on the screen. So the sample standard deviation is 12.99 to 2 decimal places. So you can see that it's not a huge difference, but as soon as you start to talk about actual statistical calculation, it will make a little bit of a difference. So be aware of which standard deviation you need to use in your calculations. Is it the population standard deviation or is it the sample standard deviation? So if you go shift 1, now we looked at all of the different types of setting in variable, which was my type 1 calculations. So what I want to do now, instead of doing the one variable calculations, I like us to look at some regression calculations. And yes, I want to clear the memory because I want a new data set. And what you can see now, because we know that regression is basically measuring the relationship between two variables, now we have got two variables, x and y. One very common question when it comes to regression calculations is to find the correlation coefficient of two variables, which if you study accounting or management, you might have come across with as calculating the correlation coefficient or the regression coefficient between two investments or two portfolios. So how to calculate the correlation coefficient? Basically, the correlation coefficient calculated by dividing the covariance between the two variables and divide that by the population standard deviations of each of the variables. And the covariance calculation is, as you can see on the screen, is a rather complicated one, because what you need to do for the covariance calculations is to calculate the mean for the first variable and then calculate the difference between every single data point in your first variable and its mean, then calculate the mean for the second variable and also calculate the difference for each of the second variable's data points and its mean, and then multiply them together, and at the end add them together and divide by n. So it's a rather long calculation, and if you were asked to do it by hand, it takes quite a long time. So here's an example. There is investment rates for a portfolio over 5 years and another one for over another 5 years. So how can we actually calculate the correlation coefficient for the following two investments? So when you actually have to do this calculation manually, there are quite a few steps involved. So first of all, you want to put your data into Excel, because then that is a lot easier and quicker to calculate. And that's probably what happens usually in real life. However, in an exam situation, you are not able to use Excel, so you would need to be able to calculate these on a piece of paper. And although you still need to demonstrate your understanding, so you can't just use the calculator, but the calculator will really much help you checking if you've done the calculation correctly or not. So first of all, what you need to put in all your data. And the data we're going to use for the first portfolio would be 16, 7, 9, -4 and 17. So these are the interest rates according to the different years. And for the second one, again, the same: 12, 3, -4, 5 and 14. Again, the different interest rates according to the year that we're talking about. First of all, what you need to calculate is their means. So you want to add all of these together. That would give you 45. And then again, all of these together, that would give you 30. And then you would get their mean by dividing this by 5. So that's 9, and dividing this by 5 again, that's 6. So these two here are giving me the means. So what I'm gonna have to do then, calculate the difference between each of the rates and the mean. What happens there is 16 minus 9 gives me the 7, 7 minus 9 gives me the minus 2, and so on. And again, I need to carry out the calculations for those and the difference between 6, which is their mean again. So 12 minus 6, 6, 3 minus 6, minus 3, and so on. Once I've got these, I need to square each of them, because remember that the standard deviation, which I need to use in the final formula, the standard deviations are the squares of the differences added all together and divided by m. So square of the first one, square of the second one, and so on the rest one, add it all together and then divide that by n, which is 5, which gives you the variance, and then take the root that will give you the standard deviation. Same for the second one. Now I have got the bottom of the final correlation, but I need the covariance, and remember that the covariance was the sum of these multiples. So if I've got the differences between the data and the mean, then all I need to do then just multiply them together. So that would be the covariance, part of the covariance calculation. So 7 times 6, 42, minus 2 times minus 3 is 6, and so on. And then what I would need to calculate is the sum of them, and then I would need to divide that by the 5, because I have got 5 data. So that is this part. So now I have got the covariance, and what I need to do now is I need to divide that by the standard deviations individually, and that would give me the 0.51. A lot of calculations involved. So how can we draw on the scientific calculator to help us with checking if we got the calculations correct? So what we need to do for the calculator, first we need to input the data. So R1 was 16, 7, 9, minus 4, and 17. and then use the arrow button, go up to the top of Y, and then type in the data set for R2, which is 12, 3, minus 4, 5, and 14. What you can see now that I have got 5 rows in each of the columns, and I have got the X and the Y column. So my data is inputted, and remember, even after I clear the screen, this is all stored in the calculator's memory. So I now want to record the correlation coefficient. So I'm going to press Shift 1, and now I need to go to number 5. That is the regression. And I have got different things in here: A, B, R, X hat, and Y hat. And R is my correlation coefficient. So if I press R and then press equal, then that's going to give me back the 0.51. So yes, when we calculated the correlation coefficient on the table, that was the correct one. But how can I check if I did the rest of them correct? If I did the means correct, or if I did the standard deviations correct? Thankfully, I can use the calculator for that as well. So Shift Stat 1, but now instead of regression, go back to 4. And what happened now? While we only had one variable, there were only a few options. Now I have got a lot more options. I still have got the option of n, which I'm expecting to give me back the value 5 because I had 5 different data. So go back again to 4. But I have got x bar, sigma x, and sx. So x bar is now giving me the mean of the x variable, which was our first investment portfolio. So if you press 2 here and then hit equal, we end up with 9. And remember that at the bottom of the table, for the mean of R1, we did calculate 9. How can I check the other mean? So go back to 4 again, and the other mean would be y bar, which is 5. Remember that was 6. So let's see if it is 6. Yes, it is 6. What else can we check? Again, go back to 4. Well, we also had to calculate population standard deviations for both x and y. Now that would be 3 for x, which is 7.56, and if you recall in the table, that's exactly what the standard deviation was for R1. And if we go back again, Shift 1 variable, and we check the population standard deviation for the second variable, that is 6.48, which is again exactly what the table calculation given us. So even though you would need to demonstrate your understanding of the whole process of the calculation in the exam, the calculator comes very handy to double check if you have actually done the correct calculations. If we go back to the statistics and look at a little bit more details what the regressions are, now you need to remember that the regression is basically standing up of two coefficients and the regression correlation coefficient. You can record those coefficients by using the different values, and x hat and y hat are here the so-called estimated values of x and estimated values of y. Depending on how much details you go into regression in your calculations, again you can use the scientific calculator to check the values of those, but for this specific example we used, it's not necessary because it doesn't use any of the expected values. One last setting in here is the 6, which is Minimax. If we go into there, that is basically quite self-explanatory. If you press 1, it's going to give you the minimum value of x. If you press 2, it's going to give you the maximum value of x. And you can record the minimums and maximums of y by pressing 3 or 4. And that was what I would have liked to talk about using the scientific calculator for statistical modes. I understand that this doesn't really cover everything that the scientific calculator is capable of. However, in modern days, you hardly use the scientific calculator for statistical purposes because all of these calculations nowadays are done by software. However, if you find yourself in a seminar situation or in an exam situation, then it would be useful to quickly check if you've done the calculations correctly or not. Here is the option for you to do so. I hope you found it useful, and see you in the next video.